Me neither. Bummer. Are we pepping today at lunch? We probably should. At least, yeah, we should. Send out the message after this. We'll see who else shows up. All right. So for today, we're jumping in, and there's some wonky stuff happening, but this is the factored form of f prime of x, I believe. And we're all on the same page now. Okay, if I wanted f of negative 1, and I don't have a calculator, how do I evaluate it? Let me rephrase that. What did you guys come up with for f of negative 1? Let me rephrase that. Should we come up with this together? Okay, I'm fine with that. So we're checking f is the good news, and here's f, right? Okay, this is 5e to the negative 1, and I'm just going to write it first, and I don't usually work left to right, but I'm going to here just because of the way I have it written, minus e to the negative 2. Everybody agree with this? Okay, if we clean it up, this is 5 over e minus 1 over e squared. And if I go one more step, could I make this multiply by a clever choice of 1 so I have a common denominator? I think I'm going to just call this 5e minus 1 over e squared. That's what I would call this value. Now, I have no idea what this is. In my head, I'm thinking 2, but I know it's pretty far off, right? It's 2.7, but 2 is easy. Roughly 210 minus 1 is 9 over 4. 9/4 around. Pretty far off, but it's close-ish. Okay, this one's way nicer. And it might not look like it. If we try to plug this in, and I'm going to make us, and whether you actually write it or not, I'm not going to physically make you do anything. But I think if I plug this in, it looks like it's going to be awful, but I don't think it really is. ln of 5 halves. Okay. Do you guys agree that this looks terrible? Except for one little thing. Yesterday, I have this kind of memory. I hope it's a real memory. Did we write a property of logs on the board yesterday? Okay. That's all right. It must be we're doing the exact same stuff right now in my pre-calc class, so I'm mixing wires here, but that's whatever. Well, what's the inverse of an exponential? The log of the same base. This is a base of an exponential, and it's e. What's the base of this log? E. So what do they do to each other? They undo or cancel. It's like the one time I'm okay with that. These are gone, which what drops out? 5 halves minus, and then this one we might need to do a little bit more with. A couple options. If there's a number in front of my log, where did it come from? It was an exponent on this. Like it was 5 halves squared. So when I do this, I'm just going to do this in 2 steps. We'll say it was e to the natural log of, I'm going to call it 25/4, because everything inside got squared. Now, I'm going to erase this in the interest of space on my page. What happens when I do e to the natural log of 25/4? It's just 25/4. That's pretty handy. So you guys will probably have an extra line on yours. And let's see, this is 50 halves, or 50/4 minus 25/4. I think this is 25 over 4. What's f of 2? As an exact answer. I'm going to give you guys a second. If you haven't done it yet, I want you to tell me f of 2. In the grand scheme of things, if this were on the AP test, can you guys tell me for sure which of these numbers is the biggest? Like, it's kind of ugly to do, right? Now, what might be okay to do? Like, I made us do it by hand just so we could get a little bit of practice with the algebra. Do you think this would really be a by hand problem? Probably not. I want you guys to check for me, and we're all going to verify that we agree, but I want approximations for these because we're going to be able to identify. So here's this approximation. I'll do this one, and it's not even approximate. That one's exactly equal. 6.25. I did that one. I want you guys to check. See that we all get the same approximations. Check with your neighbor once you do the f of 1, or a negative 1, I'm sorry. See if you guys get the same answer. Then do the same with the other one. I'll grab a calculator and I'll check mine. 5 e to the 1. So whenever you have issues with that calculator, because you weren't here when we first started looking at them, let me know. ln and e. Sorry, I'm on my other calculator, so my brain just stopped working. Right here. If you want the yellow ones, it's diamond. If you want the blue one, it's second. And then anytime you turn it on, you can always hit the home button. I would put parentheses. I think this is like 1.704. Second, that, okay. What about this one? Negative 17.653, I think, right? And you're okay to just call it 6.5 for now. Is it 4? 2.9, okay. Okay, did anybody get different numbers than these when you plug them into your calculator? And I know people are still checking, so whenever you're done checking and you get the same numbers, I'll just ask, put your calculators back down. That'll be like my sign. So it's been a while, but what were we actually doing in this problem? So kind of. I didn't write the instructions here. Check yours, because I know it's from yesterday. What's the whole point of finding these critical values and stuff? We're looking for the extrema, right? Okay, is there a biggest value here? It's this one, right? So the biggest, this is an extrema. What type of extrema? Max. Is it a global or local? And in fact, both, because like, and that wasn't supposed to be a trick question. Global is the right answer. That's what I was hoping to hear. But if it's a global, it must be bigger than everything nearby in a small area as well. So I'm just going to call it global. We're going to make the comment, and we're going to be very clear with it. We don't say it has a max. What is it? F. And you can just call it F. You can call it f of x. Has. And we don't have to be like perfect sentence here. There's no real context. I'm just going to use a colon here. F of x has a global max. Where? And this question can be worded a couple ways, right? We could say the global max is 6.25 at some particular x value. Or if we don't want to have to write all that, can we just write an ordered pair? It's at which x value? Natural log of 5/2, whatever that is. And I'll make this parenthesis smaller so it looks like it's kind of nested. Comma, what was that y value? 6.25. And we have it. Okay, this one. Was it anything? I don't think so, right? It's definitely not the global maximum. It's not the global minimum. It's at an endpoint. I'm okay with this. Okay, so what's the other value then? So are you looking here? Oh, you're looking here. I'm sorry. Okay, as we looked yesterday, we counted this as a local max, right? Because it's closed. So we have a, and I started writing a G already because I was expecting a different answer. We'll hit the other maximum here in a second. What's the other global thing? There's a global min. Where? 2, negative 17.653. And then this is the weirdest part, and it doesn't really sit right with me necessarily. Like, it just doesn't feel intuitive, I guess is what I mean. It counts as a maximum if it's a closed endpoint, right? Now, it could be local, and it will have to be local. Is there a local min or max? So why do you think it's a max? So check this out, just to counter that, just so we can see. If I have a positive x value, is it guaranteed to be a maximum? So we should probably think about what this function does. Now, realistically, I should have said global extrema is what I should have asked for, because we now have to do a little bit more investigation, but it's not going to hurt us. How do I decide what has happened? Like, I know that this is a local extrema. I just can't decide if it's a max or a min. How could we possibly decide? So maybe. I can't really follow what you're saying, but there is a way, and we can even logic it out nicely. I'm not going to put these perfect, okay? Not even a little bit to scale. Here's -1 and 1.7. There's our first one. And we get natural log of 5/2, which is a little bit positive, and it's 6.25, so it's bigger. And then we get 2, and it's all the way down here. Those are the 3 points, right? Okay, if, in a big hypothetical, if my function did something like this is still the max and the min, right? What else would we have found, though? We would have found another critical value in here. Like, there's no other option we would have had to have, because my derivative would be 0 at that point. Did we find another one, or did we only find this? This is the only one, which means I don't think it can do this. Instead of curving downward and then back up like this, and we'll talk about the language for that, if it can't do that, what's the only other option? It must go upward instead, something like this. And I did it poorly because I can't really see. We'll do it nicer. It must go upward like this, and we have something like that. Okay, with that in mind, what was this one? A local min or a local max? There's a local min at that point. Now, that problem was unintentionally tricky there at the end. If I ask you one like this again, I will make sure it's very clear. And when I ask you, rather, I'll make sure it's very clear that we're looking for the global extrema to not throw you off. Okay, should we do one more like this? Or do you guys want to get some, you want one more like this? I'm cool with that. Let's get crazy with it. Oh man, we get some pretty cool word problems here. And not even super word problems, they just give us context. All right, let's get one more here. I want us, gross. You know what, maybe not. Here we go, one more. I'm gonna give you guys a head start. And is this example Delta or Charlie? We'll just go ahead and we'll just name it a new example. I'm fine with that. Find absolute. I'm just going to call it abs extrema. Extrema, sorry. It is going to be a hard habit to break. All right, we are looking for the absolute extrema for our only function that we're going to do this with one more time, a little bit nicer of a derivative. Let's have f of x equals 2x cubed minus 3x squared minus 12x plus 8 on, we'll do the closed interval, -2 to 3. Okay, here's the deal. I don't think everybody needs to listen to my narration through this problem. Some people will certainly benefit from it. I'm going to pause it. You guys are going to start working. And when you don't know what to do, you're going to do what? Ask. You can ask your neighbors. You can ask me if your neighbors' answers don't make sense or you want a more thorough explanation. But I want you guys to try this. I'll give you a moment, and I'll be walking around. Cool. Going through, I just want to emphasize the steps. One thing that I would strongly encourage everybody to do if you haven't is when you get the zeros of your derivative, take the time, the 5 seconds, to write critical values. Because eventually we'll use the critical values that come from the first derivative. We'll have a different name for things that come from the second derivative, because all this is going to tell us different information. Make it a point to write down where these numbers came from, because as the problems get longer and we get more of them, if you lose track, you're kind of in trouble. Okay, so we find f prime. I solve it by setting it equal to 0. There's nowhere that it's undefined, and these are my critical values. Once we get here, all we have to do is just check f of x, and it's really important that it's f. Now, I don't really mind if you use your calculator on this, and realistically, you could use the calculator for almost this entire problem, is what you could do, but I need to check 4 values. What's the first number I need to check? F of what? -2. That's my first one. The next one is f of -1, and then f of 2, and f of 3. Now, there's no real penalty or any penalty whatsoever if you don't write them in order. But again, when we start getting a bunch of numbers, I would encourage it. Okay, do you guys know how to ask your calculator to help you evaluate these functions? Okay, so let's do that. I'm going to grab mine, and I want you to grab yours. I almost made you guys do it with synthetic stuff, but I'm not that concerned about it. So here we are. I'm going to just play completely naive. I don't know how to use this calculator. And I know we don't do a ton of stuff on the calculator. We will, like, realistically, just so you guys are aware, I'm not just skipping it. What I intend to do is when we get through everything, we go back through our global review, because we've done almost everything by hand at this point. We'll come back and we'll learn all the calculator stuff, so it's fresh in our heads anyway. Okay, here I am on my calculator. I want to graph or at least evaluate the function. How do I even type in my function f of x? Y equals. It's right here in yellow. It means diamond y equals. Now, I have a function from before typed in. That's okay. I'm just going to scroll up and I'll hit clear. Okay, our function, and I'm going to have to bounce back and forth. 2x cubed minus 3x squared minus 12x plus 8. Is that right? Is that the function that we just did? Okay, I want you to notice where it's stored in my calculator, and I assume it's the same in yours. This is stored right now is which function? Y1. Okay, has to be Y1. Or it doesn't have to be, but you need to know where it is at least. And just for fun, I'm going to try to do this. I'm going to copy this, and then I'm going to paste it on Y3 just to show you, like, maybe I just did something wonky, right? So I put it in on Y3 instead for some reason. I don't know why I would do that. Don't change yours. I'm just pretending like I made a mistake. As long as I know it's Y3, we're still okay. So I'm going to go back home, and I just hit the home button. Mine was stored as Y3, right? So check this. We can dig in and try to find the vars button like we do on the other calculator, or I know that there's a Y button and a Y3. I'm just going to have Y3. You can type Y1 if that's where it was stored on yours, and we should theoretically get the same thing. Y3 of, what was the first x value we needed to check? -2. And fingers crossed that we're going to get the right number. Let's check. Is it 4? Oh, fantastic. So I'm not going to show the next ones. I will show this very first thing. I'll just switch colors. I get a 4. Do you guys also get 4? Okay. Now, for this, these calculators are nice because it's still on my screen. If I just hit to the right once, it'll unbold or unhighlight everything, and I can just simply change a number. I need to check -1. So I'll just do -1 instead, making very sure always on these calculators that you have left and right parentheses that match, and -1 is at 15. What do you guys get for +2? -12. And what about for +3? -1. Everybody agree with these 4 values? Okay, we were looking for the absolute or global extrema. Is there a clear winner for who has the biggest output? -1. That's where it happens, right? And when I plug in a -1, it spits out a 15. So here we go. We'll say f of x has global, and I'm just going to do this so I don't have to write it, ... max at, what was that order pair for the maximum? Love it. -1, 15. And I think, is there a global minimum? At 2. So that's our x value. What's the actual minimum? -12. And look at that, we're done. Now, our next section, and I'm going to let you guys help me decide. As I'm going to give you time to work on the homework right now, just so you know, because I want you to practice with these things. But before you get there, I'm going to write the homework up on the board. I'll tell you it's going to be on like page 297 is where it'll be. But I want you guys to look through some of the word problems that exist on 294, 295, and 296. And I want you to identify, are there any that seem more interesting than others? So I'll write the homework up here in just a second, but I want you to tell me, where is your interest in which application on the word problems on 294 through 297? Because we've done the mathy part. The rest of it's just, let's see how it's applied in a particular problem. And as you're doing that, I'm going to get the assignment. So let's see. So homework 4.2. I'm just going to call it 4.2. We're at page 299. All right. Let's check out problems. Love them. We'll do 7, 15, 19, 23. Just trying to make sure we get some from each section. 40. 56. And I'm going to give you guys 67 also. But I want you to be very careful. If you didn't see it, my arms are going crazy. I want you to read the directions. Read the directions when you do 67. Okay, I'm going to end the video here. We have about 20 minutes almost to work on stuff. How much you guys be working on things?